everyone. This is the general introduction to understanding Fuzzers, or Allison doesn't know how to name her talks. But this is the track 2, and hopefully you all know you're at BSides. Although if you don't, congratulations, you're at BSides. So we're going to do a few things today. We're going to talk about introductions and goals. We're going to talk about fuzzing is and isn't. We're going to break down a fuzzer, sort of how you understand what these things are. We're going to talk about who uses a fuzzer and why. And then the second half is sort of craft. I was asked to give some specific advice about fuzzing, but it's hard to do that in a general case, so we'll talk about mutational coverage-guided fuzzers, the most common of which is the AFL family, AFL++, AFL itself, libAFL, the 30-plus research fuzzers we have written based on AFL, and then we're talking about optimizing bits of it and then how it would fit into the life cycle. This part's more craft than science, so it's more like practical advice, but it's also hardly airtight. And then at the end, not that I expect any of you to do this today, because when I put this together, I didn't know it was going to be the last talk, but there is a lab. It's available online. You can do it whenever. I'll have my email, and you can email me if you get stuck or have problems. So I don't expect you guys to do it today, even if you are surprisingly awake, but it is there. You can try it, and I will help you. So who am I? I'm all this stuff. I believe you all can read, even in the back. But the important thing here is I'm an academic who studies fuzzers. I'm not a vulnerability research person. I don't use them in my daily grind beyond like benchmarking them. But if you are a VR person, I would like to talk to you because I can't build a fuzzer to help you if I don't know what you want. Prior career, I was a compiled application dev. So like Rowan, I tend to build things that I don't actually use, but other people do. And besides being a BSides volunteer, I'm also an instructor or lecturer, as all PhD students are. We occupy this superposition of what the university considers convenient. But if something happened that was bad or made you feel bad, even if it wasn't a violation of the COC, I hope you all know you agreed to by being here, the organizers would still like to know about it. We'd like to make each year better. Usually there's a survey that goes out where we ask you about how stuff went and what you'd like and what could maybe do better. Cool? All right, so who I think you are. I think you're probably fried from 2 days agone, because I am fried from 2 days agone. I believe you are awesome for coming to the last talk. I know that's really hard. And I'm going to try to focus on some big picture ideas and the common stuff. Slides will be up, so if you're like, yeah, they said some cool things, I don't remember what, it was the weekend, it's already a blur, you know, I'll put that some up. So I assume you've at least heard of fuzzing, and that's why you're here, although you may not know much about it. I think you're probably relatively new to InfoSec. I need to slow down. Because BSides tries to balance content to have intro stuff, medium stuff, and kind of advanced stuff. We don't always win at organizing the schedule to make that obvious, but that is what we try to do. So I assume you are all relatively new. You probably have some developer experience. I hope you've had a CS class or equivalent, maybe a boot camp. If you're an expert, you're probably going to be kind of bored. But you can look at cute cat pictures on the internet. I won't hold it against you. If you find some good ones, let me know. So the goal of this talk is to try to give you some ways to think about framing how you use fuzzers. What a fuzzer is, what it isn't, when to reach for it, when to not. I'm going to try to avoid being prescriptive, do this, do not that, because I want you to think about the why. Why do we tell people to do these things with fuzzers? Why is that? And does it apply to the situation at hand? The greatest tool in CS is knowing when to reach for the right tool and when to put it down and get a new one. We don't really have silver bullets and we don't really have free lunches. I hope you learned something. To be honest, at this point, I'm grateful if you don't fall asleep. That's a win. And I would like you to leave here understanding that fuzzing is still more craft than science. I can tell you what it is, where we got it, bunches of things that are useful for certain classes of fuzzers, but we're still not at the point where it's a well-understood science. It doesn't have the mathematical rigor of other areas in CS. So that's why I want you to hopefully learn to apply some of this, but keep in mind it is craft. You may have to tune it. It may not always apply. It is not a universal law. We don't really have fuzzing axioms, though my advisor probably wishes we did. So then let's get into what a fuzzing isn't. I hope by this point, given this is a security conference, I don't have to convince you that vulnerabilities are a problem. Anyone disagree with that? Okay, cool. You're all awake. So why fuzzing? Well, fuzzing is a form of security automation. And we kind of need automation in this field because we have about one InfoSec expert for every, I don't know, 100 or 300 developers. And each developer probably writes a bug about every 75 to 100 lines of code. Regardless of age or experience, they keep showing up. And that simply does not scale. Even if you are bad at math, you can see why this could be a problem. So we have software that we build tools to help us. I mean, as someone who builds software, this is the part that's interesting to me. I build tools to help people. Maybe not me, but other people. So where did fuzzing come from? It was a dark and stormy night, and they only had dial-up in 1989. Ooh, yeah, okay. Well, I mean, it's sunny and 3 o'clock, so I can't really blame you for not looking scared. But anyway, a young professor was trying to work from home, which very few people could do in 1989, through a dial-up line. When lightning hits the pole, scrambles the standard in going through the dial-up line, and promptly crashes his program. He doesn't get to finish what he's working on. And what's a poor CS professor to do? Well, your CS students always need final projects. And having students solve your problems that you find kind of annoying, but not quite enough annoying to fix yourself, is a time-honored tradition. So, in 1990, we get the public invention of fuzzing. It's an article in the issue of Communications of the ACM. It is a magazine article. I have it with me, actually. I very carefully didn't bring it to the talk, because I am also fried from 2 days of con. Anyway, he assigns it to his students. What actually isn't as well known is that 2 student groups attempted the project. One half-assed it, and one knocked it out of the park and gave it their all. Guess which group is famous? The second one, right? So for all the students in the room, go big on your final projects. As someone who is a grader and a professor, I will tell you that we will give you credit for trying a lot of things as long as you document. This is why having minions is great. The invention of fuzzing. I'll have it up here. I'll have it up here for you to look at afterwards. But yeah, that is their final project. That is a pair of students. And you know, a professor helping them with the editing and providing guidance and oversight. However, the rest of the field, they are graduates in systems and operating systems, as we now call the field, and the reception kind of sucks. In fact, it sucks so much that other faculty told Dr. Miller he should drop out of CS because the research sucks so much. When I say poor, I mean mean. But he doesn't. However, the security community, and particularly vulnerability researchers, give it a warm reception, albeit they don't tell people for a very long time that they have all adopted this thing. So if you are interested in reading about it, there's a lovely interview with Dr. Miller. Again, I'll post the slides so you can click on the link. It's worth reading. Now, the fuzzer that sort of is the first most people heard of is AFL. This kind of raises to popularity late aughties, early teens, but there are many fuzzers that predate it. But this is the one that everyone seems to have heard of first. And there are various theories for that. It's got an impressive track record. It's got the screen that gives you the illusion of control. It is fairly easy to set up. And maybe it was just in the right place at the right time. I don't espouse any of these. I've just heard all of these over the year. So please be aware. And if this is interesting to you, which I'm hoping it is, the 30-year retrospective by Dr. Miller and his current students is worth a read. TLDR, classic fuzzing, still annoyingly useful. If you went to Rowan's talk yesterday, you heard him mention that he piped DevRand into student projects and pretty much universally brought them all down. Works on production devs too, even those of us with shiny titles. So, now I hope to convince you that this thing is useful and a little bit of its delightful backstory. What the hell is it? Well, fuzzing in its purest form aims to thoroughly explore the input space of a target. You can call it a victim, a fuzzy, a program under test, software under test. We suck at nomenclature. Looking for inputs that cause interesting behavior. What do I mean by interesting behavior? Well, that is up to the fuzzer creator. And what makes interesting behavior to a fuzzer is a key point of its taxonomy. Not all fuzzers consider the same things interesting. It's sort of a key thing you have to understand with working with the fuzzer. And ultimately, fuzzing in its practical form is a stochastic or probabilistic technique. It's dynamic. You have to run the code. That's one of its potential downfalls and why it doesn't fit for every situation. Sometimes you can't, or sometimes it's a really bad idea. If you want to get into the bar fight about whether symbolic execution is a subset of fuzzing or fuzzing is a subset of symbolic execution, bar is 2 blocks that way. I'm going to stay out of that fight. But the other thing you need to know is that The original Fuzzer didn't really have one of these because everything it worked with spoke standard in, but there is sometimes a need for a driver, also known as a harness, which acts as a glue between the Fuzzer output and the fuzzy input. Not all pairs need one, but if you do, you really want to make sure you put the engineering effort into it. If you are trying to knock on a thing that takes, if you're trying to knock on 100 doors, and you only actually knock on one, are you going to find the bugs behind the other 99 doors? Nah. So if there are 100 ways into your program and 100 ways to get inputs in there, you kind of need to probe all 100 if you want to find bugs. If you only probe one, you're probably going to miss stuff. Everyone buy that? This is a thing that gets overlooked by new people fairly often. Don't underestimate the value of your driver if you need one. All right, so what does working with the Fuzzer look like? I should explain that AFL stands for American Fuzzy Lop. We have this history of naming fuzzers after fuzzy furry things, which is a pun that's immediately obvious to English speakers and really confusing to the rest of the world. And that's why there are lots of rabbit jokes in fuzzing, is because the most famous fuzzer is named after a rabbit. I've managed to convince Google that I don't want the Australian Football League, finally. But anyway, you're going to start with either this pictorial diagram. Did I mention I'm not the artist in the family? You're going to do setup. Now, setup can be non-trivial. All of these steps can be non-trivial. But whatever your setup is, you're going to do it. And then you're probably going to debug it with some short fuzz jobs to make sure you have all the settings you need, it's actually doing what you want, and just sort of testing the system that you're going to get what you want. Because nothing is worse than running the thing, coming back 24 hours later and going, let's see our glorious results. And it'd be like, no permissions, exit 0, bye. And you're like, damn it. All right. So once you are you happy with the configuration and that everything's behaving itself at runtime, you're going to fuzz for real. Then you're going to review and check your results. What comes out of the fuzzer may not be gold. We have what's called the crash triage problem or the reproducibility problem. Not all of the things that the fuzzer finds interesting are what you find interesting. And not all of them are going to be reproducible because a fuzzer does not always know why. So your second thing, which is sort of optional if you're on the defender side, we'll talk about it a little bit more, you will need to analyze the results because I get messages, hey, I heard you're the fuzzing person. I got this crash. What's wrong with my code? I'm like, whatever could cause a seg fault is what could be wrong with your code. They're like, yeah, but how do I get it to tell me? I'm like, it doesn't know. It can't tell you. You have to, this is where you earn your salary. So if you are someone who has to do something with the results, analyzing it is non-trivial. And I have seen ratios north of like 1,000 to 1 for basically false crash reports to true bugs. So do not underestimate 4 and 5, and that's an area of my own research, which we'll probably not have time to talk about, but hope springs eternal. This is also called the root cause problem, because not only can a fuzzer not tell you why, it struggles to tell them apart. So it uses a series of assumption and approximation that actually don't work so well that often to try to guess, oh, this crash was different than that crash. These are two different bugs. It usually gets that wrong. And it usually errs on the side of reporting more crashes and making more work for you than accidentally hiding something that might be new. Hopefully you'll do something with the results. You've spent all that time and energy, you've used electricity, hopefully you do something with the results. Nothing's more frustrating than people fuzz and they just like drop the results. I was like, well, why'd you do all that then? You paid for that server time, aren't you gonna do something? Sometimes you spend all that time and you don't get results, in which case you might have to go back and retune the fuzzer. Is there something else you could use? Is there a fuzzer that better fits this, And then you're gonna repeat this cycle. Questions about that? This is like what the daily grind of using a fuzzer looks like. Okay, I see some thumbs up. All right, so when is a fuzzer a bad idea, right? Fuzzer's not, like, we have great tools, it's a great tool, don't get me wrong, but not every great tool is great for every job. And one of the important things in CS is recognizing that and knowing what kind of tool to reach for. So, first thing to know is you should know that fuzzing is generally hard on your hardware. It's CPU intensive, it's very RAM intensive, and if you're running that in the cloud, that's expensive. And even if you're not running in the cloud, that's expensive. You have to pay for your own electricity. You have to buy computers. You have to buy all that RAM. Probability is not always your friend. If you are rolling randomly on an even dice, what are your odds of guessing 1 through 37? You say 8-byte integer before anyone gets too cheeky. Yeah, not good. 1 in 2 to the 64, which really is really not good. So if you know you're going to have a thing where probability is not your friend, those types of puzzles are traditionally not great for fuzzing. It's also not good for truly dangerous code. If you're like, I don't know if this implant's truly dangerous, I don't know if it can escape. Like if you're worried about a VM escape, maybe don't fuzz. Because that's a problem. You have to run it. It's not static analysis. You might use static analysis to make your fuzzers smarter, but ultimately you got to run the thing. And if you're afraid to do that, or you can't do that, you kind of can't fuzz it. And as I mentioned earlier, it does not know why, which means it can't tell you why if you want to know, but it also means you often get these bad noise to signal ratios. You get a lot of reports, and you might have to go looking for that needle in the haystack. What is the one golden crash report among 1,000 turds? And don't underestimate how long it can take you to figure out the answer, especially in large old C programs. And ultimately, we're flirting with the halting problem. We're going to kind of toe up to that line and bat our eyelashes at it. And that means we have to rely on approximations and assumptions, which work 90% of the time, but if you find yourself in that other 10%, not great. The other thing you have to know pragmatically is that a clean fuzz job is not evidence that you don't have bugs. It just means you didn't find them this round. Everyone cool with that? We have this thing in CS where we really love like the newest shiny toy and it's great and it will solve all our problems, except it never solves all of our problems. So we're going to break down a fuzzer, now that we sort of talked about what fuzzing is and what it isn't. I would say that there are sort of 5 key features of fuzzer taxonomy. If you're like looking at this fuzzer and you're like, how does this relate to other fuzzers? Does it do what I want? Here are ways to think about it. What is interesting behavior? I mentioned this earlier. It's a key thing at the heart of the fuzzer. What is it looking for? How does it get its new inputs? Where do we enter that giant loop that runs until someone says to stop to get new inputs? All right, cool. How? What's the exit condition? When does this sucker stop running? And this one is sort of a little bit more specific, but relates to how does the fuzzer know if the fuzzy did interesting things? What does the fuzzer know about the source? That usually determines how much you can know about interesting behavior. So it's kind of a proxy for that question. And does that fuzzer have a specialty, a focus, magic pixie dust that makes it super special? The salespeople will always focus on number 5. So starting with what's interesting behavior. Right now, one of the dominant paradigms is coverage-guided or coverage-based. And this basically tries to approximate paths through a binary. Its underlying assumption is that the more you explore of a target or a victim, the more interesting things you're likely to find. If you want to see a thing crash, you have to get the code to execute first. So that kind of makes sense, right? And so it's going to do that by using those inserted code points and looking for paths. And it's going to approximate that by tuples. This is the AFL style of code coverage guidance, which seems to be the dominant one. Another thing you'll run into is directed. And in case of directed, you name a point in the binary. You're like, here, flag.txt, get me this. And then you look for things that get you there. Make sense? So they're kind of related, but not quite the same. Any new path is good for coverage-based, but in directed, we are looking for a way to a particular point. And then taint analysis is a little bit of an older idea. We get that from, I think, the 70s. In that case, you're looking to trace a path between input, in this case colored red, to something special like secret. And anything that gets you there is good. Make sense? And then I have never encountered a fuzzer that doesn't think crashes are interesting. So you can always count on crashing the program being interesting. And the idea is that we accept universally as a field that programs should never crash. I've only encountered one piece of software where crashing was viewed as okay. And for reasons you can ask me about that off the recording. So the next question is, where do you get your new inputs? What's the engine that drives finding those things? And I'm going to break down 3 big ideas. A lot of these can be sophisticated. There are a lot of hybrids. This is a big part of a fuzzer, and so I'm going to make it look really simplistic because it's, 330. So in the classic mutation fuzzing, which is the biggest paradigm right now, you're going to start with some input. In this case, I started with this picture of the cat. I gave him some whiskers. People like the whiskered cat. So I'm like, okay, let's take the cat picture that did really well and give it some more whiskers and see if people like it even more. Make sense? We're basically taking things that did well last time and tweaking them to see if they'll do even better. Now, generational fuzzers were sort of big in the late 90s, early 2000s. for reasons they fit really well with things that have grammars. And so you have some sort of starting algorithm. In this case, our pictorial version is a face has 2 eyes, a nose, and 2 ears. And I'm going to grab from various buckets that it says are legal and put those together. So if you've seen in your PL classes, like those grammar languages, laid out, top, bottom, in terms of binding, you feed these into that kind of fuzzer. Those fuzzers are great at this. But that's their algorithm. You can see how it's kind of different from mutation in the sense that it has a series of set rules that guide how it constructs new seeds. We say it generates rather than mutates. And then the classic fuzzer, the first one from 1990, basically you got to make sure standard in and dev random work, and you just pipe that in and you see what you get, and you don't care what happened last time. You're only interested in this time. And this is sometimes called dumb fuzzing, and I think that's a little mean because it's still effective, and it's not dumb if it works. So exit condition. The most common one I see as a researcher is scheduled duration. We run our tests and our benchmark for like set amount of times, and then we compare them to each other. The most common one I see vulnerability researchers use is user-initiated exit. They'll like leave it running in the garage, wander away for a week or two, and come back and check, I'm done with that one, turn it off. It is theoretically possible, and I've only seen this once, for a fuzzer to run out of inputs to test. It has explored the entire space, and it knows it. That is because that program only took a single 16-bit integer, and we can, in fact, brute force that entire space. You're probably not going to see that one, but in theory, it exists. You could actually explore the whole space and declare yourself done. And then there are fuzzers, namely libfuzzer, which finds a single crash, and it's like, I'm out, mic drop, I found a crash, go fix it, and exits. That one's not popular with VR people for fairly obvious reasons, but is popular with developers because it's presumed you will go fix the bug. So you may have heard the term Whitebox, Graybox, Blackbox. I hear the EE department is responsible for these terrible terms. But in a Whitebox, it means you have the source. It's possible for you to know just about everything about your fuzzy that you could. And then a black box is what the VR community tends to work with. That's a highly optimized, compiled binary. It's good to go. You probably don't work there if you're working with black box binaries, just saying. And the thing that you see very commonly now is gray box. That's what's used in AFL. And it's called that because it usually starts by taking the source, heavily instrumenting it with code points and extra information, and then running it. So you get the speed of the black box, but kind of approximate the information of white box. So like white box is slow, but you have lots of information. Black box is fast, but you don't got a lot of information, and this gray box seems to be this like sweet spot in the middle. Cool? All right, and the next question is, what's your focus or specialty? If you're searching for fuzzers, you might actually start with this question, because if you're fuzzing a kernel or a car, you kind of have different requirements. I've encountered fuzzers for cars. We have ones for web APIs, BooFuzz, which is the workshop going on right now. We have fuzzers for kernels. I have met fuzzers for routers, ones for websites. You know, we have different fuzzers meant for different jobs. So you can think of this as specialty. All right, so I've sprouted a lot of theory at you. Let's try applying some of that and hope that it sort of puts the pieces together. So starting with AFL++, because that's like the most common fuzzer that people encounter when they're starting out, was interesting behavior. Well, system crashes, as represented by seg faults, universally interesting, so I hope that's not a surprise. And it's coverage guided, so it's going to look for new coverage as approximated by tuples. Make sense? It's going to get new inputs because it's a mutational fuzzer. It's going to mutate things. It's going to potentially mutate them various ways. It's got a lot of stuff in there. But ultimately, it's going to mutate prior inputs based on their priority. If you heard Rowan mention power schedules, that's a way of prioritizing seeds and going, yo, I think this one's a winner. Put that one at the top. Do that one next. It's got a fancy name and a whole paper, but ultimately, that's the idea. And then it's exit condition. Well, technically, it's user-initiated exit. Most people script it. I use it in a benchmark, so I just plug into the benchmark parameters. Please run my test for 24 hours. Okay, thanks, bye. But the other thing I often see that isn't talked about is your fuzz job gets killed for resource hogging. And if you're going to fuzz in the cloud or on hardware that's not yours, you might see this one a lot more often. So I'm going to warn you that that one's out there. And then how much does the fuzzer know about the fuzzy source? It's a gray box, so you're usually running a heavily instrumented binary, which leads it's usually built from source. People have spent some non-trivial effort trying to like retrofit instrumentation into compiled binaries, and that's a whole line of research unto itself. And then does this fuzzer have a specialty? It does. It's compiled userland binary applications. That is the intended target of AFL out of the box. Rowan mentioned those are heavily fuzzed, because there are a lot of fuzzers that do this right out of the box. Makes it easy. And it has about 20, well, probably closer to 30 now, research ideas rolled into the source code. So this thing does a lot of tricks. It's got a lot of mutational strategies. It's got a lot of stuff. You have to go in there and turn in all the knobs and decide if they're right for what you're doing. It doesn't do them all out of the box. A joke about AFL is it's an hour to set up, it's a lifetime to master, and the documentation could use, if you're looking for a volunteer research project, I suggest that one. All right. So who uses a fuzzer and why? If you remember nothing else from this talk, if you are shopping for a fuzzer, before you can do that, you have to identify your needs, your goals, and things like your platform. What are you fuzzing? What do you want out of it? And all those things before you can go find it. If you read fuzzer, like, oh, you'll read blog fuzzers, this fuzzer's great, that fuzzer's trash, I don't know what you're talking about. And the reason is because they've got different goals. So, not everyone wants the same thing in fuzzing, despite what people on the internet might tell you. All right, so we're going to start with the people who really kind of put fuzzing on the map, although they didn't invent it. It's the offensive folks. They want to find vulnerabilities. They want to find it fast. They generally want to find stuff before everybody else. And they give 0 Fs about why. They just need to know that it's reproducible and stable, right? So they're looking for fuzzers that will be fast to find. They want to find vulnerabilities, not bugs. Bugs are basically a waste of their time. And they want to find tricky things. And ideally, source code not required, because realistically, most of the time, they don't have it. I'm going to skip that section, but here's a list of fuzzers that people like that might like. Every slide has one of these. The next group to sort of pick up fuzzing was kind of the defensive people. They kind of want to find all the vulnerabilities, and they kind of want to find them all before release, so they have a slightly different timetable. And they do care about why, because they have to convince people like me to fix them. They're going to look for things that probe as much of the product. They kind of need it to fit into the rest of the security workflow, what works for their teams. They're more interested in vulnerabilities, but painful bugs are okay too. The devs will yell at you if we knew about them and didn't tell us. True story. All right. So sort of the last group to pick up fuzzing in industry is the software owners. That's people like me, or was like me. I guess I'm retired now. You're looking for things that find vulnerabilities, but all the bugs are your problem too. So I care about crashes and hangs in a way that the offensive people do not. I need to find them about release, and I can't fix them until I know why. The why is a very big part of the equation from the software owner's perspective. You often look for different things, too. I'll be looking for things that target a specific commit. I might want to fuzz recent code. I might want to fuzz a new parser we put in there. I'm looking for stability because my to-do list is already way too long, and fixing software that should just be working already is not my idea of fun. I need bugs and vulnerabilities. As Rowan mentioned in his talk, snapshotting and time travel are really helpful for that. And code coverage is actually interesting to at least the QA people because you want to make sure you can tell your leadership that yes, all of the code is tested or all of the code we can reach is tested. And then the group I am in now is academic researchers, which are much maligned, but and part of that is because our goals are not always your goals. It might be one of those three. It might be studying software testing as a field. We might be looking at something else in CS, and fuzzing just looks like a good venue to study it, or at least to get funding to study it. Let's be honest. I'm looking as a researcher for things like known benchmarks. How will I test this thing? Is it publishable? Is it citable? Is it a good thing to build new stuff on? Because I need to build stuff to graduate. So the two big fuzzers, and I say big might be a little bit of a stretch for VMF, but are libAFL and VMF, which is Vader Module Fuzzer. And it came out this summer. It's what I worked on over while I was an intern. But so ultimately, what you're going to do is develop your own so that you can write a paper about it and graduate. All right, so let's talk about the craft side. Okay, I didn't fix that slide. Great. Generally, here's a large wall of advice about general behavior. Your driver matters. Again, if you knock on one door and there are 100, you're not going to find the bugs behind the other 99. You might need more than one, depending on the configuration. You need to understand what makes the fuzzer tick to figure out how to optimize it. The stuff you would do to optimize a grammar fuzzer, which uses generational techniques, doesn't work on a mutational fuzzer and vice versa. That's why I didn't want to be prescriptive in this talk. Mutational fuzzers are the big business right now, but that doesn't mean that's going to be the case in 10 years. So generally, whatever powers exploration, if you can only spend time optimizing one area, focus on that. Right, if you use mutation, focus on the mutation strategies, turning all the ones on that will help you. If you know dictionaries will be great for the target you're working on, spend the time to turn those on. But those are like really sort of practice tuning and getting to know things. In general, if nothing else, remember that making more things crash is good. Every fuzzer likes crashes. The more stuff you can make crash, the better off you'll be. And that means, TLDR, use as many sanitizers as possible. All right, how many people in here know what sanitization is? I don't mean the garbage man kind. Yeah, okay, good. I talked to someone yesterday and they're like, I don't know what that is. So here's the slide where we explain it. So sanitization is really about making more things crash. If you're familiar with many languages, C in particular is one we like to pick on because it was written to allow you to write an OS. And in an OS, you need to do a bunch of terrible things that you should never do in regular code. So the language will let you do them because it was designed to write Unix. And that is what C is meant to do. It is not meant for lots of other programs that we use it for. It was meant for operating systems and all the terrible things they must do. So we have this buffer here. Who knows what an overread is? Okay, so buffer overread is when you go past the end of the array and you're not supposed to. And in C, nothing will stop you from doing that because you must have meant to do it. And it's not the place of the language to tell you what to do. That's the philosophy of C. It's not my place to tell you what to do. And all the people are just like, oh, tell me what to do. Don't let me do bad things. Too late. Anyway, so we have this buffer. And we could write off of it and we wouldn't know because like overreads don't always result in crashes. You see something you shouldn't, but that does not necessarily mean you will result in a seg fault. Everyone generally buy that? What address sanitization does in particular is put poisoned memory all around your buffer. So if you try to read off of it, it will crash your program immediately. If you try to write to it, it will crash your program. So this is how you turn things that are not innately destructive, like overreads, into crashes. And there's versions for the heap, there's versions for runtime, there's a whole bunch of other ones. But the idea is fundamentally the same. Try to make non-destructive behavior as destructive as you can in the hopes that you'll notice that you did it. Got the idea? Cool. All right. We're talking about seeds in particular. This was a request from a board member, so hopefully they're happy with this. Because mutational fuzzing is the dominant paradigm, seeds matter a lot because they are the thing you use to mutate. If your seeds suck, your mutation's probably going to suck. Makes kind of sense? You know, that's the thing that's powering the heart of your fuzzer. You want to make sure your heart's got as good material as possible. So this is a big area. And you can choose to mutate areas of seeds. You can mutate whole seeds. You can do a lot of different things. But they are good news for some targets and bad news for others. So most of the cool features are off by default in most fuzzers, and you have to go in and go, oh, no, I want to fuzz just this section because that's the actionable section. Or no, mutate the whole thing, go blow it up. That's what I want. So when you're working with mutational fuzzer, you're going to want to know what should you micro-tune. And in general, things that are very structured, SQL, XML, those sorts of languages, you're going to want to use like a dictionary or some sort of thing that will fuzz those keywords themselves. I think in AFL, the feature is called auto tokens, right? Because then you can fuzz the grammar as well, kind of. Now, the biggest area of contention within mutational fuzzing, at least in the AFL world, is what to do about the initial corpus. Because that sort of algorithm starts with what happened in the prior iteration, what did well, let me go mutate it. So what happens when you start and there's nothing in there? You need something, right? And that's usually provided by the user. And there are sort of two schools of thought about how much effort you should put into that. And the first one, which is sort of the conventional one, you'll see in vulnerability research, and you'll see it in some bits of the literature, which is that it's very important, and you should make sure that that starting corpus is as awesome as possible. The other form, which you see actually more on the internet and more dominant in blog posts, is that it's not worth the bother. If you just run the fuzzer longer, if I'm going to run that fuzzer for 3 weeks, I don't care. And a lot of that comes back to an experiment that the AFL author did, whereby he just put in hello world, left it running, and walked away and came back the next day. It's like, hey, I got valid JPEG files. Isn't that cool? This blog post is highly cited, and I'm picking on this particular author because I got referred to it 5 times, and they have more than 80 years of security experience across all of them. So this particular blog post about Linux kernel fuzzing was super popular. But you can see how he's like, oh, yeah, they're supposed to be important. I don't feel like dealing with it. It worked for that guy. Let's go. So who's right? Who thinks the first guy is right? The first theory. I see 1 or 2 hands. All right, who thinks the second theory is right? Brave souls, okay. Who thinks this is a trick question? Ah, you are awake. Yes, it's a trick question. So actually what my research showed initially is that they're both right, just not all of the time. I have my theories, and this is where I tell you that this is hardly airtight. This is the end, this is sort of an error of craft. Here is what my data says. I can't tell you that this is axiomatic. It could be the structural level, size, topology, or something I don't know about. But in general, the more structured your data, the more that initial corpus seems to matter. If you were fuzzing something like SQL, you really want to put the effort in. My SQL job ran for nearly a week, and the computer might as well have been off for all it accomplished. However, the job with the valid corpus, made of nice lots of inputs stolen from their unit tests, did great. So if you look like SQL or XML, you want to spend time on that initial corpus. On the other hand, the less structured you are, I think the closer to binary data, if you look like JPEG or TIFF, if you run for more than 24 hours, you don't really care. The results looked about the same. So I would say that in general, you don't lose anything by spending 30 minutes to make that initial corpus and make it good, but you could lose stuff, right? You can only gain, you can't lose. So at the very least, you can be lazy and run strings on your binary and pipe that into the input directory. If you're working on an open source project, somebody did the work for you. Go take their test cases. Copy, move, done. You know, like you don't have to spend like a ton of effort mentally crafting things if you're working on an open source project or something that already has a test suite. Go take the test suite. Or, you know, if that doesn't work for you because you're working on something super elite and secret, or God forbid you have developers who didn't write any tests somewhere along the way, run the fuzzy, look for some strings, grab some interesting magic values. If nothing else, grab the globals. They're usually useful. Okay. All right, integrating fuzzing in a software lifecycle, the hard part. This is also known as fuzz left. This is what Rowan's team is working on and hopefully making inroads in Intel at. But there are no free lunches and there are no silver bullets, and this is one of the places where that's true. You're gonna need a lot of server time. You need to pay for that server time. And you're gonna need to do it more than once. You're also probably gonna need more than one fuzzer. A couple reasons for that. Finding all the bugs is harder than finding just one. Different parts of the system usually need different fuzzers. If you're fuzzing a binary, you're gonna want something different than if you're fuzzing a web client. I mentioned that fuzzers have specialty. You need the right tool for the right job. But the other reason is different fuzzers will find different bugs even on the same fuzzy, on the same victim. So we know that if you were really trying to thoroughly fuzz something, you're gonna probably running like 3, 4 different fuzzers on the same thing, which your ops people may not want to hear if they're in charge of the bill. Also, you're probably going to need to fuzz for a lot longer than you think you do. A lot of the blog posts talk about finding stuff after 5, 6 hours. In practice, you probably need more than 24 hours. You probably need closer to a week. Perhaps on the alpha branch. And your adversaries, all the VR people I know just like leave their fuzzers running for weeks at a time. So if that's what your adversaries are doing, even if ops does not like the bill, you should think about doing it too. They're also usually running more than one. And one of the ways you can sort of save the bill a little bit is to reuse your seeds. If you're using something like AFL, there's always an output corpus at the end. Here was the state of my fuzzing queue when I exited. You can feed that yesterday's job into today's job and try to sort of chain things. So you're not revisiting the same thing all the time. It can take a little bit of like scripting to do that, but I believe that's within everyone's skill set. And don't underestimate the amount of time you're going to need for analysis, triage, and messaging with your dev team. If they are not understood, they will not be fixed. I will tell you that indecipherable reports get ignored. In my case, if I got one of those, it would then go into the bucket for later analysis, which usually meant summer intern projects, which if the bug is filed in December is not great. So one of the things you need to know if you own this side of the thing is communicating with the developer team about what it's going to do. And don't underestimate how much time and energy that takes. All right, final slide. And if anyone is brave enough to attempt the lab, here are the links. You select AFL, it's going to use Docker, so if your professors and the people you're talking to for interviews are like, I love Docker, we love to see Docker experience, get some Docker experience. You should have basic introduction to systems, or at least some familiarity with C, assembly, that sort of end of the world. You can do them locally or on GCP. I mentioned GCP in the lecture description. It's about 30 minutes a lab. I have never tried this on Windows, so if you have Windows questions, don't ask me. And I can be found here. My email is naaktgeboren@pdx.edu. I'm on the BSides Discord, although we didn't seem to use that this year. They listed my LinkedIn, but I don't really use LinkedIn, except when students need connections. So that's not a great way to get my attention. But email us. Generally, email is a great place to get me. This slide will be uploaded at the talks directory, and I guess at the end of the conference. But if you do vulnerability research, I want to hear about what's hard to fuzz for. What's useful but non-destructive? Do you need heap leaks? Do you need to leak? What do you need? As someone who does research, it's nice to know that I will be doing something that people will actually use and find problems they care about. Likewise, if the VR community complains we don't listen, come tell me, I will listen. All right, and that is the end of the talk. No, wait, that one's not mine. Which means we enter the scariest part of the talk for me, which is open floor questions. What do you got? All right, one in the front.
Yeah, so let's say that I'm more like engineering manager, or trying fuzz left kind of a person. And I'm really curious about what your thoughts are on the strategy around corpus, right? So is it better to spend a lot of time on a corpus and sort of encode my preconceptions about where my software is broken into that, or is that giving myself a blind spot into what the fuzzer could be searching for?
Okay, so the question is, as an engineering manager, if I put a lot into the work of the corpus and try to point it at areas that might be dangerous, am I biasing the fuzzer in a bad way or a good way? Is that about right? Well, a very prominent vulnerability researcher, who does not like to be named, says that a good harness and good seeds is how she blows things up. She may or may not mean that literally, given who she works for. And so what she usually does is she goes into the code, she does reverse engineer, and she identifies areas that she thinks look bad or fuzzy, pardon the term. The parsers in particular have been a long target of fuzzing because they're often hand-coded and contain bugs. And so she'll identify that, grab things from that area, and she has great success with it. So I'd say if she's doing that, you should do that because the adversaries will use it against you. You're welcome. And again, if you're running for a very long time, I think you need to worry less about biasing the fuzzer towards areas and making sure it's got enough ammo to get to all the areas. Other questions? I saw some other hands. All right.
VMF looks really cool. Why should I use it?
VMS looks really cool. Why should I use it? Well, VMS purpose is to be a laboratory fuzzer. It's meant to test new ideas. It's meant to be modular, so it has some of the same goals of libAFL, of porting things. Unlike libAFL, it wasn't tied to AFL itself, and so it's got some cleaner boundary lines. I have had students spin up on VMF in 30 minutes, and I can't say I've ever had anyone spin up on AFL's internals in 30 minutes. Emily spent a lot of time making sure that it was well encapsulated and well engineered. And libAFL and AFL have been phenomenal successes, but they were someone's side project. So not quite the same as we're going to take an architect with 30 years experience and ask them to design the right thing. So VMF is new, it's kind of a baby fuzzer, but it's a great laboratory. So if you're I want all the power because I want to go bug bounties, VMF's probably not right. But if you're I would like to test my new ideas and be certain that it's actually my idea and not Complog doing all the work, VMF is better. So the targets that I had classified as semi-structured were kind of in the middle. You got some gain from using an initial corpus that you'd actually pulled and filled with valid seeds, but it wasn't as dramatic as SQL or XML, things that are highly structured. So human structured or what we call semi-structured, you do get some gain. I don't think it's, 30 minutes is not going to cost you a ton, but your gains are not going to be as dramatic as it were something like SQL. So it's still a good idea for you, but it's not you must do this the way it kind of is for SQL and XML. Make sense?
Yeah.
Okay. Other questions, or would you all like to go to closing ceremonies? right, well, thank you for being a great audience. I don't think anyone fell asleep. I'll see you all at closing ceremonies.